On these last two, we're going to look at some arithmetic and algebraic applications of exponential functions, exponential equations. So on this first one, we're talking about some money that's been deposited, and we have to assume that there are no withdrawals made. It's going to compound interest on a monthly basis. The formula for this, it'll perhaps look different in some different textbooks, but the textbook I'm currently using has the formula written the following way. The future amount or future value is equal to P times all of the following, where P stands for the principal or present value. It's multiplied to all of the following. Where R is the rate of interest expressed as a decimal, N is the number of times per year that interest is compounded, and T is the time in years for which it compounds. So in part A, we have how many years. Going back to the original information, $1,500 was put in. We've got an interest rate of 3%, so 0.03 as a decimal. It's compounded monthly, so N is 12. That 12 shows up again up in the exponent, and this is going on for a time T of 5 years. Notice how it's only N down here, where it's N times T up here. It's not just 12 here, and it's not 12 times 5 down here. On the TI-30, this could be typed in all at once. But if you did have to break it down, 0.03 divided by 12, add the 1. So we finish the parentheses. And then we're going to raise it to whatever N times T is. Now, if you've got parentheses on your scientific calculator, you put parentheses around the exponent and have it do the multiplication, and then raise that power, raise that previous answer to that power. But 12 times 5 is 60. I want you to notice what we have here so far is something that's between 1 and 2. Very rarely will you get a question where you get something bigger than 2. It takes, what that would mean is if it's 2 or bigger, the money is doubling or more. And it takes a combination of a good interest rate, something higher than 3%, number of times per year that it's compounded, and how much time goes by. The interest rate, the 12 times per year, and the time, these are all pretty low. Now I multiply that by 1,500. Now we're supposed to round that to the hundredths place, 2 places after the decimal point, because except for gas prices, that's what money gets rounded to. So that's going to round to 1742.43. And since the 1,500 was in dollars, so is this. $1,742.43. So that's a gain of almost $250 into 5 years. But you have to start with a good amount of money to begin with. The interest rates, how many times per year, and the number of years, those are all pretty low.